All right, in part two of this video, we were looking at the pivoting process. We went all the way through it. That's the longest part of these problems. Again, this is number 8 from section 7.4, which wasn't designed to be, well, it wasn't given as a problem that we're going to do all the way through. It was given as just something to set up the Simplex tableau. But we did that in part 1. In part 2, we had to pivot twice. Once about the 3 up here to get to this matrix, and then once about the 2 here to get to this matrix. So see part 2 if you want to see that. Now we're just going to interpret our results. So what I do when I'm looking at the results, I look at that last row. That's really the key here. And I'm just going to write it out as an equation. Now, I will say we could reduce by a factor of 3 right away if we wanted to. Everything there is divisible by 3. Specifically, we're going to be solving for z, so we're going to divide by 3 at some point. But I'm not going to do extra work if I don't need to. These columns are x1, x2, x3, s1, s2, s3 for the slack variables, z, and then the constants over there. So I don't really need to divide everything by 3. We're just going to say this last row as an equation would be 0 times x1, right, plus 45 times x2, plus 0 times x3, plus 3 times s1, plus 6 times s2, plus 0 times s3, plus 3z equals 252. Okay, and the way we interpret this, we're trying to maximize z. We want z to be as big as possible. And these other variables, they all have to be non-negative. So they can be 0, or they can be a positive number. So these variables that made it into this equation, if any of those were a positive value, then they would ultimately bring this number down when you subtract them over and make z smaller. So our maximum z is going to occur when all 3 of these are equal to 0. So that is the first part of our kind of conclusion here, is that x2 and s1 and s2 are all just 0. And then that gives us 3z equals 252. And now we can divide that by 3. So when we do that, we get z max equals, 3 goes into 25 8 times, with the remainder 1, then 12 4 times, right? So 84. So our max value of z is going to be 84. I'm kind of putting the whole solution together here. And then the other piece of this is to figure out the other variables, x1, x3, and s3. And once you have all this over here, it's really easy if you know how to do it to find those other variables. You basically go through these rows one at a time, the top 3 rows in your final Simplex tableau, and just kind of see it there. So we know that x2, s1, and s2 are all 0. So if you look at that first equation, x2, that's 0, right? So negative 12 times x2, that's negative 12 times 0. It doesn't do anything. S1 is 0 and S2 is 0. And then everything else here has a 0 coefficient. So what we have is 6x1 equals 36. You can write the whole thing out if you want. Remember, you're going to plug in 0 for those 3 variables for x2, s1, and s2. And so what you get is 6x1 equals 36. So x1 is going to be 6 in this solution. Okay, and then we do the same thing in the next row. Again, that's 0. 2x3, that's 0, equals 36. So we get 2x3 equals 36. And so we get x3 equals 18 when you divide. And then finally, the last row there, if you look at it again, that's 0, that's 0, that's 0, and we have 3s3 equals 132. If you divide, we're going to get s3 equals, let's see, 3 goes into 13 4 times, 12, 44. And so that's the solution. You get that max value of z of 84. One way to get it at least is to have x1 be 6, x3 be 18, and S3 be 44. The other variables all are 0. If you watch a video on an application problem with one of these, you start to get a better idea of like what this all means and how it's useful. The slack variables have meaning too. But for this one, I'm going to stop it there, and that's our solution in that box there.